the last thing that I'll mention is that it is not just the individual performance of the model that matters here, because if we're predicting for bed management decisions, the bed manager is going to be more interested in questions like, if I have 16 patients in my ICU right now, how many will still be there in 2 days' time or in 4 days' time? Say that if they are planning around the use of the space in the hospital. So to test this, we did 500 simulations where we took 16 random patients, including a random point in their stay. And then we made predictions based on these patients. And then we also have the true values for these patients as well. And then we tested how similar are these results. So we find that about 1 day later, the model is getting roughly the right answer. But then as time goes on, the model is slightly under-predicting the number of patients that will still be in the ICU. And this makes sense because we always knew that the model would have a tendency to under-predict because of the skew. So even with the other loss function, there's still going to be some tendency or some reluctance from the model to predict too high most of the time. But in general, this is fairly good calibration. If, for example, we were going to use the median model that is static, if that would always predict 1.7 days, we would see just a step function here. So it would predict no one is going to leave until 1.7 days, and then everyone is going to leave, and then we're at 0. So that really isn't useful for those purposes. So just to say that it's not just the individual performance that we should be looking at here.